This is just a quick video on notation as it pertains to higher order derivatives. And notation in calculus ends up being actually an important thing to talk about, because it can both confuse you or help you make sense of problems if you use it correctly. So just some, and again, what I think makes it confusing as well is that you've got, historically, you've got Newton and Leibniz discovering calculus independently using their own notations, and what we've sort of done here is adopt both of them, and we're expected to kind of be fluent in both of them. So you'll see that the context will kind of determine what notation you use, and often it doesn't matter, you can just choose. So if a function, the first derivative of a function y, we might just indicate with that prime. That's usually nice because it's quick. That would obviously mean the same as dy dx, which I'm going to first write as this, d over dx of y. And the reason I'm doing that is because you want to view this d dx as almost like an operation. I'm taking the derivative of y. And for short, you could write that as dy dx. Not surprisingly, for the second derivative, we use two dashes. Y double prime is equal to, well, we're taking two derivatives. We're taking two derivatives of y, which we will usually write as d squared over dx squared of y, which you'll often see as d squared y over dx squared. All right. Similarly, for the third derivative, I'm just going to jump right to the sort of the exponent looking part. Right, I'm taking three derivatives of y, so d dx times d dx times d dx of y, which we can write as three derivatives of y, which we will write as d cubed y over dx cubed. Now, one thing you'll notice is here I put parentheses, but you'll often see that that's omitted. Probably it's kind of lazy if you think about it, based on how I've been expressing it, because it's not the x that gets squared. Dx is its own thing, but nevertheless, that's the notation that's adopted. So, so in general, after we get to three dashes, it becomes unreasonable just to keep using dashes. So you usually take the fourth derivative by putting a 4 in parentheses. To distinguish it from the exponent, raising y to the fourth, and that's going to be represented as 4 derivatives of y, or d fourth y over dx to the fourth. And so in general, we can say that the nth derivative is just dn of y over dx to the n. All right, so there's just a little notation lesson. And again, you just want to make sure you understand that this doesn't mean, for instance, that this doesn't mean that you're taking the derivative and squaring it, taking the first derivative and squaring it. This means taking two derivatives, and you got to pay attention to where those twos are located. And that's why I try to draw it out specifically by using that first example here with the d dx. Using function notation and an example, we can take the first derivative of f of x here, indicating it with that f prime. So that would be 10x to the fourth plus 12x cubed plus 3x squared minus 14x plus 11. And we'd indicate the second derivative with two tick marks. So that would be 40x cubed plus 36x squared plus 6x minus 14. We can take three derivatives with this notation to get 120x squared plus 72x plus 6. We can take 4 derivatives, and notice I had to change to the notation with the numbers in parentheses, and that would be 240x plus 72. And of course I could take one more to give me 240. And we might as well finish this off. The 6th derivative is going to be 0. And then after that, all other higher derivatives are going to be 0 as well, right? So, because the derivative of 0 is 0, so the 7th derivative is going to equal the 8th derivative. It's going to equal the 9th derivative. It's going to equal 0 for all n bigger than or equal to 6. All right, so there's some notation you'll want to try to adopt and use correctly as you're doing your calculus problems.